explain you my 9th experiment in Unix and Linux Lab, which is some inter-process communication using pipes. So there are two types of pipes called named pipe and unnamed pipe. So in named pipe, my main objective is to create two processes. This one creates a pipe and writes string to the pipe, and process 2 opens the pipe, so reads that string and displays the number of vowels in that string. So in unnamed pipe, there is only one process. The parent process creates the pipe and writes a string to the pipe. So child process reads the pipe and makes all the vowels in that string uppercase and display. So first of all, I will explain about the unnamed pipe, how it's implemented. So this is the process 1 for creating my pipe, where I will be entering my string. So I have included my c/types.h header files and fcntl.h header file and c/stat.header file. So initially I will be declaring my file descriptor and my id as int, and this is my array of characters buffer and nk node. I will use my system call for creating my pipe. So my pipe is the name of my pipe. 0755 is my octal representation. So this is that permission. So if my id is equal to 0, I say my pipe is created, else my pipe is not created. So if I want to enter my string, enter string, so in that case I will take the input from the user, that is buf, and if I want to open, I will be using the open system call and opening the my pipe, and I'm using the permissions as o_read write permission I will be using. So and after that I will be using the write system call to write that into that my pipe. So it has 3 arguments: file descriptor, buffer, and size of the buffer. And finally I will be closing the file descriptor. And now moving to the B part, process B. So this is the process, and I have included the same header files over here, and I have also declared the file descriptor and open system call used to open the my pipe, and I will read whatever the contents are there in that my pipe using the file descriptor and size of the buffer and the buffer itself. So these are the 3 arguments I will be using inside the read system call, and I will return bytes in integer. So finally I am printing the buffer in that pipe as buf, and then make a loop till the size of the buffer, that is 100. Then if my buffer of pipe is matches with AEIOU, or if it matches with AEIOU, then in that case I will make my buffer to upper, and then have my increment the count variable, so to display the number of vowels. So I am compiling my output now. cc unix 9 db.c. So initially the pipe is now created. So for creating pipe I have to enter my string. So let my string be welcome, and now I have to compile the second one, the read file. So now you can see here the buffer in pipe is welcome, which is the same as that we have given here. So in this case we have written it into the my pipe, and then in this case I am reading it using the read system call, and then finally printing the number of vowels using count variables. Moving to the name pipe. So this is almost similar to this one. This is the unnamed pipe. Parent process creates the pipe and writes a string to the pipe. The child process reads the pipe and makes all vowels in that string uppercase and display. This is the program. I have included the same header file as was I included in the previous cases, like c/tags.h, unistd.h. Here also I have included the file descriptor, which is of 2 integers, and I have used bytes ID and initialize count equal to 0 for calculating the number of vowels. Now use child PID for calculating the process ID of the child process, and string and RB are the two array of characters having size as 100. And I have created a pipe system call using pipe of FD. It has only single argument. FD stands for file descriptor. So this pipe system call will return an ID which I am storing it in ID. So if I match with the if statement, if my ID is equal to 0, I say my pipe is created, else my pipe is not created. So in that case, I enter a string. So this part is for pipe is created. So in that case, I will enter a string from the user, that is ampersand string, and I will be writing my contents into this file using the write system call. It has 3 arguments: the file descriptor, string itself, and the size of the string, which calculates my string length plus 1. So if my child PID, which is calculated using the fork system call, and fork system call creates a process having a specific process ID. So this child PID, if it matches with 0, I say my child process is this get PID and its parent process, that is get PPID, which stands for get parent process ID. And now I will be reading my content using the file descriptors and RB, which is my same array of characters and size of the RB. I will be storing it in n bytes, and I have a loop from I is equal to 0 to size of RB. Size of RB means my 100 size. So till that I have a loop, I run a loop, and I will check my condition if my contains an array matches with small caps A, E, I, O, U. In that case, I will change it to uppercase and then count the number of vowels present using count plus plus. And then finally, I will print the reverse string which is inside RB, that is the 2 uppercase one. So after these changes made, we will print RB, which is the reverse string, and then the number of vowels as count, and then finally printing the parent process ID. So my pipe is created, and I have to enter my string. Say welcome to lab. So my process ID, parent process is created with the process ID is equal to 24068, and this is my child process ID. Its parent is same. This is the parent process ID, and this is the received string in uppercase form. So number of vowels is 3. You can see here my pipe. This is the pipe I have created over here. And this is that welcome I have written into this pipe. So this was my 9th experiment. Thank you for watching my video.